Hey everybody, this is Larry. This is day 13 of the Leetcode Day Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's farm. Today I kind of woke up late. I don't know, I just wasn't able to sleep. And then I did 13 miles. I didn't really plan it for this, but I just kind of need to get the moods and the vibes out of the system and kind of stabilize myself a little bit. So I don't know, not very fast, 13 miles or 14 miles or whatever. But just to kind of see that I can is the longest one I had this year so far. So that's kind of good. But yeah, let's take a look at today's problem. We have, excuse me, of 1922. Count good numbers. Okay, digit string is good if at the even indexes are even and odd indexes are prime. Okay. For example, 2582 is good because the digits 2 and 8 at even positions are even, and okay, they're prime. Given integer n, return the total number of good digit strings of length n. Okay, since the integer may be very large, return it 10 to the 9 plus 7, right? Okay. Okay, I mean, first, remember the mod. But, yeah, I mean, I think there are a couple of ways you can think about this one. I think you just do it one at a time, right? Because it is just literally, n could be pretty big, so actually, I was going to say one digit at a time, and if you do a for loop that goes n, then it's going to be a really bad time, right? Okay, I mean, then in this case, it's just about visualizing. I thought I could be a little bit lazy, but honestly, there are really only two type of indexes, right? On odd digits, so on odd digits and then even digits, maybe. I don't know. I don't know if I draw in a way that makes sense, but anyway, for odd digits, there are only 5 even numbers, right? And then for even digits, there are 4 different choices, right? So this, I guess we're doing combinatorial problems next couple of days, but yeah. So then on even digits, there are 4, and on odd there's 5, right? So we just have to do the math on how many odd digits are there, right? So given n, the number of odd digit, right? So if n is 2, you have 1. If n is 3, you have 1, right? So that means it's just round down, right? So n over 2, right? So odd is equal to this. Even is just n minus odd, right? And then now we can just do power of odd, 5 to the odd power, because each, yeah, right? Oh, I think I mixed them up. Even index. No, I mean, I think I mixed up anyway, but this is the only part of the problem that's confusing anyway. So the first digit, because I think, okay. So what I was doing was that I was counting from the least significant digit, which is, I don't know how I mentally think about it, but in this case, this is actually not. So, okay. So we just have to be a little bit careful and calibrate. So the first, that means that even will always have more numbers, right? Because we're counting from the left to the right, so 0, okay, so this is still the case. It's just that maybe it's the same. I actually just flipped it, but I had to verify, right? But yeah, so that means that on even digits, we have 5 of them, right? And then each of them, each even, we have 5 of them, right? So it's just this times this, and then we are good. Unfortunately, we do have to mod, but even if we mod it like this, it is too it's going to get too big, right? Because this gets too big, and then okay, well, to choose an actual big number, right? And this will probably time out. And why does it time out? Well, this time out is because this requires like 1,000,000 digits or something, maybe literally, maybe not. I forget what I put in, but okay, well, yeah, maybe it would literally have 1,000,000 digits, which is a big. It takes a lot of data, it takes a lot of time, and so forth. So you just have to make sure that you're doing mod power, and that's it, really. That. But yeah, and that's it. Hopefully, yeah. Let's give it a quick submit. All right, and we are Gucci. Yeah, 1839-day streak, and there we go. Yeah. What's the complexity of this one? This is gonna be linear time, linear space, right? Keeping in mind that linear isn't the size of the input. The size of the input is the number of bits. For every bit this is going to be, the power function is linear in the size of the number of bits, right? Because for every bit, you either choose this, if you write out the mod power code yourself, you could see it, right? It's just a divide and conquer thing. So it's for every bit, you have two choices. So it's going to be linear, right? And it's the same thing for, obviously the same from here and here. So yeah, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Quite a short video for once. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.